Good afternoon and welcome to the Plant Engineering webcast, Safeability, analyzing the relationship between safety and reliability. I'm your moderator, Bob Vaver, Content Manager for Plant Engineering, and I'm happy to join you today on behalf of Plant Engineering and its 350,000 touchpoint readers worldwide. We're thrilled to have a good friend of Plant Engineering and an outstanding leader in maintenance and reliability, Sean Eisenhower, CMRP, the founding partner of Eruditio and the Institute at Patriots Point. Sean specializes in business process management, adult education, strategic planning, organizational change management, leadership and reliability engineering, and has led improvement initiatives for industries such as pharmaceuticals, metals, petrochemical, paper, and power generation, among others. He's an engineering graduate at North Carolina State University, go Wolfpack, and has become an expert in the implementation of holistic reliability solutions using tools such as total productive maintenance, reliability-centered maintenance, and root cause analysis, as well as Six Sigma and Lean to drive significant bottom-line results. Sean's a past Plant Engineering Future 30 honoree and a 2011 and 2014 U.S. Science and Engineering Festival Nifty 50 speaker, as well as being the recipient of the Solution Magazine Best Article Award. Sean, welcome back to Plant Engineering and to our webcast today, and thanks for joining us.
Thank you very much, Bob. Really appreciate the introduction and look forward to kind of sharing with you guys a little bit about the link between safety and reliability today. All right, so we're going to go ahead and get started. So today we're talking about a word that I made up. We were sitting in the office thinking about the relationship between safety and reliability. It's something that we've seen a big change in recent years. Many organizations have made substantial changes to their safety programs, and I'll show you that in a few minutes in the slides. And we were really thinking about, okay, what can we learn from safety and apply directly to reliability? And then as we went a little further with that, we started thinking about, okay, well, if we improve reliability, what does that do for safety? So there's definitely a really strong connection there, and that's part of what we're going to talk about on the call today. So just quickly, this is what you've seen and what we want to talk about today. And again, we're going to talk about how we might change our focus, change our tactics. We're going to look at some techniques, both from the safety and the reliability world, and talk about how they may fit back and forth between both sides of the house. And we'll really wrap up with answering a few of your questions from the question and answer section. So Safeability, the made-up word that we came up with, at its core, what we were talking about here was risk identification, risk reduction, risk elimination, the act of education, communication, continuous focus, the fact that you need a process or a system, and you've got to have that focus on continuous improvement with measures. And if you think about safety, every single one of these would apply. We're out there actively looking to identify risk. We're looking to reduce or eliminate that risk. We do some of that through education and communication, but definitely through that continued focus. And I can do that same exercise and go back through with reliability. Again, reliability is about reducing risk. It's about eliminating those reoccurring failures. Again, a lot of that is education and communication. So that's what's at the core of the concept that we're talking about today. So we're going to talk about in this first part the safety side, the safety first. Here we're looking at safety improvements that were not good enough. We still have work to do in many facilities, and we're going to look at a couple safety tools. So I pulled these statistics directly from OSHA just recently, so these are pretty fresh, and a couple things that I learned from that. Since 1970, workplace facilities have been reducing their illnesses by 65%. So that's a pretty big improvement over the last few years. And I think if we think about our facilities individually, many of our facilities have made great strides in the area of safety improvement. We've been able to reduce our injury rates. We've been able to make it just a better place to work from all different angles. So I think that's a very important point. And again, you see worker deaths are also down. In fact, from 38 in 1970 to 12 a day in 2012. Now, don't get me wrong, that's not as good as it needs to be. We're going to continue to strive and push on and reduce that number going forward, but that's definitely a substantial change. So I started asking myself, well, what's different? What have we done in that safety world that we might be able to bring over and create the same culture from a reliability standpoint? Before we go on any further, though, of course, the safety numbers still aren't quite good enough. In fact, as you can see here, 4,405 workers were killed on the job in 2013. So we've still got a lot of work to do, and that continuous improvement piece will continue to be a big part of that. So we've got to keep it in the forefront, and I think that's a big part of what's happened in the safety environment is they have kept it in the forefront. If you think about it, they have toolbox meetings every morning with the maintenance craftsmen, and they're sharing things that have happened with other facilities. They're talking about problems that they faced and issues that they want to make sure don't reoccur. So I think that's one of the things that we've seen with the safety improvement is it's always in the forefront. It's always something we're talking about. So let's talk about those toolbox talks. I don't know if everybody does toolbox talks, but many facilities do, and it's just that quick discussion at the beginning of the day before everyone starts their work and they distribute out across the facility. They're 5 to 15 minutes long in general, covering basic topics, and then typically at the end they'll be handing out the work orders and things and beginning their day. About 5 minutes of that, though, in many of the facilities that I work with is devoted specifically to safety. So they're talking about how to make sure you're wearing the proper PPE. They're talking about glove selection. They're talking about wearing the appropriate safety gear from an eyeglass protection standpoint or whatever the case may be. But they're always making a point about all of those safety items that we want to be addressing. Now, what if you did the same thing with reliability? So what if we started every one of those morning meetings with 5 minutes on safety and then 5 minutes on reliability? So in that section, we could talk about lots of different topics that we want to keep on the forefront, and I'll share some of those with you in just a few minutes. The next thing that we can do is we can learn from that process, because I don't think that 5 minute reliability topic needs to be prepared by the reliability engineer or the reliability leader or the maintenance engineer or the maintenance manager. I think that individual topic needs to be shared from various people around the room. So maybe you charge one of the craftsmen with going out and finding a reliability topic that they want to talk about on the next meeting. That topic may be something near and dear to their heart or something that they found through a recent root cause investigation, or it could be something as simple as how to use a bearing heater. All right, but they have to go out and they have to research that on the internet. They bring that into that session. They're learning a lot of additional items while they're out there in the area. So we're rotating it through the team. We're learning through that collection process. Some of the places they may be able to get their information can be blogs. I know my Reliability Now blog, I keep quite a bit of information on there, and I'll show you that in a few seconds. But also original equipment manufacturing sites carry a lot of information about the safety implications of the equipment that they work with or how to use it safely, and those can be topics that can be shared. Tool sites, the manuals that you have right there on site have information that they can use as part of their reliability share, and any other plant communications, maybe things from other facilities that have had recent reliability issues and what we've learned from those and shared across the network. The last piece here is, send them out and let them Google away. Let them see what they find, because while they're looking for that reliability topic, they're also finding a lot of other good information that they'll retain going forward. So I mentioned blogs. I'm a big fan of blogs. I think it's a great place to get reliability topics for this kind of a session, because most of these topics are only going to be 5 minutes, and most of the blogs that are out there today take 2 or 3 minutes to read through, so it's a perfect fit. You can go out to any one of about 20 or 30 different blogs in the reliability space, find one you like, pull down that messaging, and then during your next reliability minute, you can have a quick conversation. Now, the one you see on the screen today happens to be from my blog, and it's one on precision maintenance and how to use a torque wrench. So this would be a perfect example of one that we might cover during our Reliability Toolbox meeting. Couple of rules, though. The internet can be a little sketchy. I'm sure we've all heard stories. So I do definitely like to be very careful where I pull information from to make sure that it's actually true. This hasn't been a big deal with the reliability space, but there are hoaxes out there. There are things that maybe really aren't quite best practice, and some folks have put them out there as such. So we definitely want to be careful and think about that, and maybe after the reliability share, you have a little discussion about it during each of those sessions to kind of wrap it up and wrap it into your culture. The second thing is the internet does change. So if you find a good source, if you find a good website or a good material, I highly recommend that you go ahead and pull that material down and save it on your computer and use it as you see fit going forward. It's really unfortunate when you find a really good blog or you find some really good material and you put it on your bookmarks, and then you go back to get it later and you see the page is gone or it's no longer available. So I love to pull that stuff down. I have a special folder on my computer where I keep a lot of those, and then I can go back and pull them very quickly when someone calls and asks about a specific subject or I want to share a specific thing with an individual. So here's a few toolbox topics that you might use from a reliability standpoint. These are a couple that I have definitely used in the past. You might want to spend 3 or 4, maybe 5 minutes talking about how to use a bearing heater. You know, a lot of facilities I go into, they're really not big fans of precision maintenance. They haven't really embraced that concept. In fact, I would say they probably spend more time on what I call percussion maintenance. That's where instead of using that bearing heater and sliding that bearing on, just hand me a hammer and a chisel. I'll knock it right in there. All right, so in this piece, I can start to introduce the concept of precision maintenance, how to use that bearing heater to better install that bearing, and what that does to the reliability of the facility. Obviously, using a bearing heater and sliding that bearing on is going to give you a lot longer life and a lot more time between failures. The next one you see there is using special bearing installation tools. Again, instead of banging on the inner or outer race and causing defects in that bearing, there's quite a few tools out there from various manufacturers that actually cover that whole bearing surface and allow you to slide it in by pushing on all of the areas instead of just 1 or 2. How to use sheave pulley alignment tools. So if you've got sheaves and pulleys within your facility and you're not aligning them, that can be costing you a lot of money and a lot of downtime from a reliability standpoint. And with a few quick discussions, you can really start to address that. Ultrasonic lubrication, another great tool, something that I'm seeing a lot more of in the marketplace. I can now hear that lubricant hitting that bearing surface and know that I truly have lubricated that bearing. I can begin to hear it escalating in volume as I get enough grease in there and I start to approach the too much side of that. So you've got another great tool there that's very easy to explain in 3, 4, 5 minutes there in that toolbox session. Using infrared to verify repairs. We can talk about many of the new infrared tools that are coming to market at very, very low cost, and I can use those tools to verify that what I've done actually fixed the problem that was originally identified. Selecting correct lubricants. You know, all grease is not the same. I know a lot of us know that, but unfortunately out in the facilities I see people just grabbing whatever grease gun's closest to them and going out and lubricating the bearings. So here's a point where we can really talk about what happens when you mix those greases together. Preventing oil contaminants. You know, oil is the lifeblood of your equipment. It's running through all those various assets out there, and if I'm not taking good care of it, then I stand a real situation of inducing a lot of failures. You know, interestingly enough, based on some of the surveys or some of the research that we've done, some of the dirtiest oil in your facility is the oil that's coming in from your suppliers. So if you're not filtering that oil, if it's not being filtered before it goes into the equipment, that really can be a big area and a big problem for you. So it's a great thing to talk about with your crafts and help them to understand. So if we did all those kinds of things and we started introducing those to our craftsmen, and then they started hearing that on a regular basis, and it become part of what the leadership ask about as they're spending time, I think very quickly we would be able to see that we would knock off some pretty serious root cause problems there with some of these topics. And if we can, if we can improve the reliability of that asset and not have to do emergent repairs, we've also improved the safety. And again, that's that connection back and forth between this. The emergent repairs are very, very risky compared to a planned and scheduled job. And I'll show you that in a few metrics in a few minutes. I love single point or 1 point lessons. I don't know how many of you guys out there are using them today. I'll show you a couple of examples of them here in just a few minutes as we go through. But the idea here for me is that I do break the rules a bit. I don't just put one lesson or 1 point on each of mine, but what I do is I keep it to one page. And in that one page, there can be concepts that I want to explain, models that help people understand what I'm trying to do. And I take these out. And I've seen this from a safety standpoint. People will post safety shares on break rooms, in the walls, even on the posters in the back of the bathroom door. So I've seen them everywhere, and I think we can do the same thing with reliability. If folks begin to understand how all of these things work together and see them on a regular basis and know that it's part of what we're doing, that new culture that we're creating, then that, I think, will get us closer and closer to that Safeability that we're looking for. So posters, daily management boards, single point lessons, all of these give us an opportunity to communicate this new idea or this new concept of Safeability. So the next thing I want to look at, metrics has been a big part of how we've been able to improve safety. So let's talk a little bit about how we might be able to do the same from a reliability standpoint. Now this is a single point lesson here on performance-centered metrics. And what I've done here, and I had worked with a great team of folks to put these together, but what we were trying to do is really refine our metrics, because so many facilities today have hundreds of metrics. We have EAMs, Enterprise Asset Management Systems. We've got computerized maintenance management systems out there today. They're capable of generating and accepting an unbelievable amount of information that then can be converted into metrics. The problem is we get very overwhelmed from a metric standpoint. So what we were really hoping to do here is take a look at our metrics and really drive them to be performance-centered metrics. And you'll see that we look at, what are the goals of the organization? What metrics can be used to accomplish or drive those behaviors that we're looking for? How long should it be a focal point of the organization? Many facilities that I go into today, they've been tracking the same metrics for 15 years. And in reality, in the last 5 or 7 of those years, the metric really hasn't changed. Either we've flattened out and plateaued, or they've learned exactly how to calculate that metric so that they get it right every time. So what we want to do here is really think about, okay, we don't need this holy metric that we're going to keep forever. We need a metric that drives the behaviors we're trying to change within the organization. How long do we think we need that, and when can we discontinue it and move on to other things? We think about risk when we think about metrics. When you're looking at it, what could this induce? By measuring this metric, what might we drive in the wrong direction just based on the metric itself? So we're looking if any unintentional consequences might exist. We're looking to see if there are any constraints. Or is the organization going to be able to measure this behavioral metric that we're looking for? Compliance. What do we need to put in place to enforce or reward the organization if we choose to use this metric? And then is it an interlocking metric? In other words, does it lock in with other metrics to help us better understand the organization? So this is the idea of performance-centered metrics. There's a lot more information available there on the single point lesson that you can take a look at as you have time. Now here's another look at that, and I have 4 of these single point lessons here, and now I'm talking about a metric and what it's really after. What is it really going for? Some of your metrics are going to measure things like effectiveness. That could be route compliance from a PM standpoint, from a preventive maintenance standpoint. It could be efficiency, actual versus estimated. It could be quality, emergency work or percentage plan work. All those kinds of things measure that quality aspect. And then we have productivity. Is the maintenance labor balance correct? And then there's innovation. What are we doing to get better as we go forward? And that could be things like labor and material estimates. All right, so when you're thinking about your metrics, think about all the things we talked about in the earlier section, and then think about moving through each of these categories and driving yourself toward innovation. The next piece that I think is very important for folks to look at is transition planning for your metrics. If you're going to pick metrics to drive organizational change, you're also going to need to know what values you need to be at and when you want to be there. So as you move in, you'll see that there is a goal that you're going after, just like we saw on the first slide. There is time. How long should it take us to get there? There are steps along the way. What do those metric values need to be? And how big should those steps be? What can the organization really do within that time period? So there's limits, there's action plans, there's people who need to own those metrics, and there's communication that's going to have to go back and forth to help the organization even understand why we're measuring those metrics. So these are some of the same thoughts that we've used to drive the metrics around the safety side of our organizations. Now we can take those same thoughts and really take our metrics away from just being a standard list of metrics and really focus them on the behaviors that we want to change, lock those behaviors into the new culture, and move on to the next piece that we want to measure going forward. So the next area I want to look at is problem solving from safety. Safety they've done a very good job of really beginning to understand the causes of many of the problems that they face. So what we want to look at is, are we doing everything we need to do on the reliability side to understand the causes that we're facing? I spend a lot of time in a lot of organizations that are only using 5 whys. And I want to talk about that just a little bit with this single point lesson that I'm sharing with you today. If you're only using 5 whys, which is a very good practice because it's getting people to think about drilling down into the problem and understanding some of the underlying causes. But what you want to see is all the causes that contributed to that problem. An example I'll show you in the video in a few minutes is going to actually walk you through the transitional root cause process that you see on the slide. And you'll see how if we just use the 5 whys, we may miss many of the contributing causes. But more importantly, we also may miss the low-cost solution. So if you're just using 5 whys, I was down in a facility in Brazil a few years ago, and they were just using 5 whys within that facility. And in that case, what was happening was they would go through, they would think they had a root cause, they would implement that solution, it would fail again, they would go through, again, think they had the root cause, but unfortunately it would then happen again. So what they were doing was they were building a branched fault tree, one branch at a time through 5 whys, and that obviously comes at a very big expense because every time that failure reoccurs, they're losing credibility within the organization. They're also having a substantial amount of downtime from an operations standpoint. So I'll share with you a video here in just a second that goes into a little more detail. But before I do, the next thing that I want to show you on this single point lesson is the striped area down below. And what we're looking at here is it's very easy, especially with many of the facilities, to get into this concept of just trying to figure out whose fault it was. So if you're seeing those kind of behaviors within your facility, you're really not drilling down deep enough. In fact, the first layer you see there, the red layer, that's the physical layer. And once you get past that physical layer, we're going to step down into what's called the human layer. And the human layer is where some people are stopping, and they're trying to say, well, Bob caused this problem, and so therefore we should punish Bob. But in reality, if we dig deeper down into the problem, we'll find that there are systemic and then even latent roots within the organization that are causing or allowing Bob to do what he did. So, you know, in your facility, if you see the organization trying to blame an individual, you need to ask yourself that next question. What in our organizational structure, what in our business processes, what in our systems allowed that individual to make that mistake. All right? And if I can understand what allowed that individual to make that mistake, then I can go about solving that problem, and that problem is going to solve many other problems across the facility as opposed to just punishing one individual. So that's just something to think about from a root cause. So the next thing that we're going to do is we're going to look at a quick video clip here. This is about 4 or 5 minutes. It's part of one of our Sustaining Skills video series, and it's going to introduce you guys to this concept of branching that 5 why out transitionally into other tools that I might be able to use depending on how big the problem is. So I'll go ahead and have you guys start the video for me.
When we discuss RCA, we use a method called Transitional Root Cause Analysis, or TRCA for short. It is made up of 10 tools that can be explained and understood in a very short period of time. In the next few minutes, we will introduce you to 3 of the 10 and explain why we consider them transitional in nature. We will start with what we categorize as the tree methods. These are 3 tools that build out into an upside-down tree-like structure. The first one is called the 5 why method. It is common in the industry today and is a basic root cause tool. It is created simply by asking the question why multiple times to create one causal chain. If we take the 5 why diagram and branch it out by adding more elements at each level, then we get a better representation of all the causes that come together to create an effect. This transformation of the 5 why is known as a fault tree. This method allows us to easily see more of the factors that led to a failure. But sometimes we need to show a bit more information to make the graphic more meaningful. If, for instance, an effect can only occur when all of its causes exist at the same place and in the same moment in time, then we use the word "and" at that junction. If we eliminate either one of the causes connected by the "and," then we can eliminate the effect. On the flip side, if either of the causes could precipitate the effect, then the word "or" would be placed at the junction. This would be read as "this or that could cause the effect above." This allows you to see that both possibilities must be addressed to prevent the cause. These 3 tree methods transform from one to the next by adding one new step or feature as needed during the root cause process. First, we take a 5 why and branch it to get the fault tree. Then we add "and" or to get a logic tree. 3 powerful tools with one-step transitions that can be used as the problem requires. Let's take a look at a practical example that involves the event of a computer room fire. First, we ask 5 why questions. Why did the fire destroy the room? Because a computer ignited. Why did the computer ignite? Wires shorted out. Why did the wire short out? Because the wire was bare. Why was the wire bare? Because it was rubbing the case. Why was it rubbing the case? Not pushed into the wire mount. What are we missing? Can we truly feel that we have lowered the risk of reoccurrence? Let's look at the fault tree next and what other causes might exist. Now, if we had only completed the 5 why, we would have missed 2 other required causes and possibly missed other options for lowering the risk of reoccurrence for fire. Fire always requires ignition, but also needs fuel and oxygen. A simple electrical short would not alone destroy a full server room. Therefore, we may choose to address the fuel causal chain or the oxygen cause within our solution. With just this first portion of the fault tree, we begin to understand more about the issues. We now begin to understand that there was not a system for eliminating the oxygen like a halon fire suppression system, and that there were boxes present that served as fuel. These become 2 more options for use in our solution analysis. As we think more about the details in the original 5 why, we realize that we have not considered all of the possibilities for how the wire became bare. So we add in an OR symbol to our tree, completing the transition to logic tree. Now we can work to decide which side of the OR occurred, or we may choose to address both in order to lower the risk to an acceptable level. Even without completing the full logic tree and adding other causal chains, you can see the value in the transitional method and how it can improve both the effectiveness and the efficiency of your analysis.
Okay, so as you saw in the video there, very simple example, really boiled down a little bit so that we could get it all in there. But I think you begin to see by transitioning from that 5Y into that fault tree, we're able to see a lot more of the contributing factors and really identify what the best solution for moving forward is. And then if you add in the ands and ors from logic, it allows us to see those ands, I just have to eliminate one side or the other. Whereas with the ORs, I've got to address both of those, and so that'll become a big part of my problem solving going forward. If you want to learn more about the transitional root cause methodology, let me know. I'll be more than happy to share it with you. But it's a great way to very simply create some tools that'll get you a little deeper into your problem solving. So the next area I want to focus on is this focus on risk. And risk, now we're talking about whether this be from a safety standpoint or whether this be from a manufacturing or reliability standpoint. So in the maintenance and reliability world, we do failure mode based maintenance. We take the time to do an FMEA, a failure modes effects analysis, to understand how those individual assets fail. If I understand how that asset fails, I can make sure that my maintenance strategy addresses each one of those failure modes in the most appropriate way moving forward. So this is a really good area to really start to focus on in your organization, because if you can make your preventive maintenance task more failure mode based, you can eliminate the tasks that aren't adding value, that aren't addressing a failure mode, that were added because someone was uncomfortable or needed to add another step to the PM in the middle of the night without understanding the root causes. So if you go through this process, as you get rid of that extra work, you start to refine that PM down to something that is much more manageable and really does exactly what you want it to do. By going through that process, you've got less time that equipment is exposed or could possibly have a failure induced upon it. And not only that, you're lowering your risk to the craftsman as well. So real good area to focus here is going through and looking at your assets, doing those FMEAs, understanding how they fail, and making sure that your strategies truly only address the real ways. Now the other piece to remember too, and this is the tie back to safety on this, a failure modes and effects analysis, all you're doing is looking at the function of that item and then trying to understand how it could not meet that function. We do the same thing on the safety side. We're looking at an asset, or we're looking at a process, or we're looking at something and trying to understand how could it go wrong, how could someone get hurt. So again, using the same tools in both camps, we're able to lower the risk by really focusing on those things that are likely to happen. We've got new risk coming into the marketplace or coming into the world in which we live, and we need to be aware of those. One of the things that many of us are facing in our facilities are aging assets. Aging assets aren't nearly as safe in many cases because they maybe haven't been guarded or built or designed the way that we might build them today. So that's a problem from a safety standpoint. And from a reliability standpoint, if no one's taken care of those assets, you could be sitting on a little bit of a time bomb. They could have slowly, because of lack of maintenance or because they haven't been taken care of, they could have had a lot of potential failures more or less put into that system over time, and now we're going to deal with those at the latter part. The next risk that we're facing is counterfeit parts, and we're seeing a lot more of this over the last couple of years. The University of Tennessee is building a new curriculum right now where they're going to teach folks about counterfeit parts and the risk associated. And I am seeing more and more of these counterfeit parts in facilities all over the world. I was in China working a couple of years ago, or about a year or so ago, and saw quite a bit of these counterfeit parts firsthand, and now I'm beginning to see them here in the U.S. So definitely want to keep that in mind. It's not like the old days. It's not where, there's something misspelled on the package and it's just a dead giveaway that it's a counterfeit. Anymore, these counterfeit parts look just as good as the originals, and sometimes the craftsmanship on them is better than the original product. The problem you run into, maybe it's a bearing, and it looks just like the SKF bearing that it's supposed to look like, but unfortunately the metallurgy is whatever metal was available when they needed to pour it. So you get that product into your facility, you get it installed, and then it just doesn't have the life that you would get from a bearing with the proper metallurgy. You see a few more examples along the bottom of the slides. There's some spark plugs, some bearings, and some capacitors there, and you can see the handiwork inside that capacitor. So we definitely know we're not getting what we were hoping for out of that moving forward. So that's going to become a bigger issue and will continue to grow, and we need to be aware of that risk and be looking both from a safety standpoint as well as from a maintenance and reliability standpoint. The next area that you see that I think we're going to see some new risk is additive manufacturing tinkerers. And these are really kind of a subset of counterfeit. But what I'm talking about here is 3D printing. We're starting to see a lot more 3D printed items in the manufacturing area. Now, most folks are using them for simple things like switches and buttons and things that they want to repair or replace that have been damaged. But we've also started to see some other products from the metal side that are getting into the process, and unfortunately, because they were printed with a metal 3D printing process, they aren't the same metallurgy as the original parts. So they're not able to stand up to the stresses, and we're seeing some failures associated with that. So that's just another thing to be aware of. That has not been as big of an issue, but we have seen 2 or 3 examples of that already. Now, another area that focuses on risk, and many of you guys may be thinking or talking about this now, the new ISO standard, ISO 55000. That standard has now come to the marketplace, and it focuses on things like what do the assets provide from a value standpoint. It focuses on how the organization manages those assets. It focuses on the leadership and workplace culture that's needed in order to get the maximum value out of those assets going forward. And asset management really gives us the assurance that those assets will meet their required purpose. So it's really looking at all the different risks that are out there, and it is very much a risk-focused process. So again, if you're thinking about ISO 55000, you're thinking about managing risk, and I think that's an area that you're definitely going to want to use some of these tools within. Now, this is what the landscape looks like, and this is from an organization called the Global Forum on Maintenance and Asset Management. They have an asset management landscape document available for free download, so you can go to gfmam.org and then download the Landscape 2 document and see a little more about what all of this ISO asset management process is as you go forward. So there's something you may want to take a look at. But the other piece or point that I want to make here before we move on, just like asset management needs a landscape or a system for managing it, safety has had that system for quite some time. So if you haven't built reliability or asset management systems within your organization, processes for how you're going to do work, if you haven't documented who's responsible for those steps, how they're going to be accountable, when they need to be done, all those kinds of things, that's a real good place to start, because as you document that process, you can identify the risk, you can mitigate or eliminate those risks through process steps. Now you may be asking yourself, the ISO 55000, I'm not familiar with this. What does that mean, or what is all part of that? So what I've done is I've put a slide here, and this is the asset management subjects from that landscape document that I mentioned a few minutes ago. So you can see on your screen all the different areas that it focuses on. What I'd like for you to notice, though, is the sixth area. The very last area is focused on risk and review. So again, in this risk section of this presentation, you can see how predominant risk is in the asset management subjects. Here's a copy of that document that I mentioned, so that's what you're looking for if you go out to the website to see more about it or download a copy. So reliability and safety, let's talk about the link. Let's talk about is planned work safer, and let's look at PDM and how that fits, or predictive maintenance and how that fits into our reliability programs. So I love this graphic. Ron Moore produced this graphic a few years back when he did a study. It's also in his Making Common Sense Common Practice book. And what you're looking at here, the blue line represents the percentage OEE for a facility, and the red line is their safety rate. And I think it's very interesting when you look at that. As their OEE increases, their safety rate or their injury rate goes down. So we can see very quickly by looking at that graph, it is very obvious the correlation between both maintenance, reliability, which is a key part of OEE, and what that can do from your safety standpoint. But I think it's even more common sense if you think about how we do things at home. If at home we're running through trying to get something done very quickly, we're reacting to some failure that has occurred, maybe the hot water heaters quit working, whatever the case may be, there's a lot more risk associated with that. We're using the wrong tools, we may not have the right parts, we may not take the time to truly think out how we're going to do the job, and that's when our possibility of injury goes up substantially. So I think if you look at the graphic here, you can see very much that correlation between OEE and injury rate, but I think if you think back to your personal lives, you can probably feel it even more there. So planned work is safer, there's no doubt about it. If I'm planning that job, if I'm figuring out what tools I need, what people, what parts need to be there, what risks are associated with it, when it needs to be done, when I'm looking through and planning that job, I can lower, and many facilities have seen this, I can lower that injury rate because I don't have people out in the facility firefighting. So this is another single point lesson here, and this one here focuses on preventive and predictive maintenance and precision maintenance. But specifically, I just wanted to talk a little bit about how we use preventive and predictive maintenance within the facility. And if you think about it, when you're doing many of the invasive preventive maintenance tasks, you're getting in, you're taking covers off, you're inspecting the asset, you're putting the asset at risk from a maintenance standpoint, and you're putting that craftsman at risk as well as they're having to do that invasive task. So the interesting thing is if we can use predictive maintenance, now we can go in and do that same inspection, maybe even better, with less exposure, less time in the area, and without the invasiveness of having to take things apart. And the example I think about, if I have a gearbox in a facility, if I'm going out on a preventive maintenance standpoint and taking that cover off and inspecting those gears and then putting all the bolts back in and tightening it back up, that's a high-risk operation for that equipment if I have a dirty environment. Because all that dirt can be blowing around in the air and get right into that gearbox. I could accidentally drop a washer or a nut into that gearbox. Anything could go wrong there. So the risk is very high from that preventive maintenance task. On the flip side, if I take, let's take vibration as an example. If I take a vibration box out and I go out and do the same inspection, I don't open the gearbox. I don't even shut the gearbox down. I very quickly can ascertain what's going on with the gear set inside that gearbox without ever having to expose it to the risk associated with hands-on original preventive maintenance. So that's one of the ways that predictive maintenance obviously is going to help us lower the risk from a reliability standpoint. From a safety standpoint as well, as long as we keep in mind the safety rules around using those predictive technologies around live and powered equipment. So making the change from where we are today to that more safer, more reliable world, one of the big things that we've got to think about there is how do we get people to embrace the change that we're looking to have? And the last slide I'm going to share with you today is my philosophy on project and change management. It's a single-point lesson that contains many of the things that I think are really important. If you look at this graphic, down at the bottom you'll see a model called ADKAR. For me, that's how you change an individual's behavior. Directly above that, you'll see a string of boxes. That is the Cotter's model for organizational change. And for me, where the first one was about changing individuals, this is about how to change the organization. The last thing you see there is Ken Blanchard's Situational Leadership 2, and what that's about is how do I change me as a leader to help my organization change the culture and the behaviors that I want to have. So looking back through this, the very bottom is going to be about changing the individual. The black boxes is about changing that organization, and the model that you see that's in 4 colors there and the curves is about changing me as a leader within the organization. So this can really be 3 tools that you can use very quickly to help your organization move either further down that safety continuum or further down that reliability and asset management continuum to get them where they want to be. I'm going to look very quickly at them because we just have a few minutes left. But the first one I showed you down there is the ADKAR model. And ADKAR is an acronym that stands for awareness, desire, knowledge, ability, and reinforcement. And I'm going to use our single point lesson to demonstrate that model. So if I want someone to understand project and change management, the first thing I have to do is make them aware of what project and change management is. In my single point lesson, that's the box up there labeled topic description. If I want to create a desire in that individual to change their behaviors, then I've got to tell them why they should care, and you'll notice that's the second box on my single point lesson. If I can create a desire, then I can pass on knowledge, and that's all of the core of my single point lesson that we're talking about now. And then hopefully if I'm working with that individual, I'm going to have them demonstrate that they understand what ADKAR is, demonstrate it in their facility, demonstrate it on a problem that they're trying to solve. By demonstrating it, they're showing me their ability to use that in their environment. The last thing you see is the reinforcement step, and that's about the metrics and processes I need to put in place to make sure that that culture truly changes and they're able to move forward. So if you look at the ADKAR model, we've used that to build the single point lesson that you're looking at as well, and that's what we want to do to drive that change forward. Now, the next model you see is the Cotter model directly above it. That's the black boxes with the various words in them, and you can use these very well to begin to build your change process within your organization, whether that be that change process to improve safety, reliability, implement a new CMMS or EAM. It really doesn't matter. These are the core steps that you need to go through. You can learn a lot more about Cotter's model by reading his book, Leading Change, where he gives you a lot of the details. Or if you'd like to hear about it with more of a maintenance and reliability spin, give me a call and we can definitely talk through various organizations that have used that tool. Now the last one that we're going to look at very quickly is Situational Leadership 2 by Ken Blanchard. And what you see here, this is about what I need to provide to the people in my organization to help them change. So as you go through each of those phases, you'll be directing and then coaching and then supporting and then delegating as they move through the change. And that's a really great topic to help you as a leader within the organization drive that change forward. So to kind of wrap it all up, I think you see many of the tools that we use over on the safety side definitely can be pulled directly over to the reliability side. If you're already using root cause tools over there, then you're able to pull those over and use them from a reliability side. People are already going to be familiar and comfortable with them. If they have an action tracking system for tracking follow-up items, you may be able to use that, and again, it'll be something people are already familiar with. So you really can blend the line or blur the lines a little bit between the safety side and the reliability side of your organization. Of course, if we can improve reliability based on the OEE numbers we saw, we'll also then be able to improve the safety of that facility as well. So they go hand in hand. Many of the tools are the same, and at the end of the day, that's why I think there's this term, this blended term called Safeability. With that, I'm going to open it up to questions, and I hope everybody enjoyed the presentation today. If you'd like to check out more on the blog, you can check it out at reliabilitynow.com, or send me an email, or give me a call on my phone, and we can talk more about anything you've seen here today. Thank you very much for your time, and have a great day. Ready for questions.
Thanks, Sean. As always, a great presentation. We've got time for some questions. Please type your questions into the Ask a Question box on the screen. We'll get to as many as we can today. Those that we can't, we'll send those down to Sean and get answers, and those will all be posted at planengineering.com. Within a few days of this presentation and the Q&A session, will also be available for on-demand viewing. So you'll be able to get an email from us when the archive version of this webcast is ready. You can also access the webcast via the Plant Engineering homepage. Let's go to a few questions that we've got some time now before we get started, and I think this is a good place to start. Sean, how would you include predictive maintenance, condition monitoring in comparison with safety?
Well, I think predictive maintenance and condition monitoring both, they play such a big part. You know, the more we can use those technologies, the lower the risk can be. And, you know, just a quick example, if we look at infrared, you know, in the past we used to go in and we would take a torque wrench and we would torque all the connections in electrical cabinets once a year because they would loosen up over time. That's a high-risk environment that we're going into. We're having to suit up to do that. We're having to take the assets down, lock out the equipment. There's still a lot of danger involved with that process. When you look at the infrared tools and the infrared windows that are available today, I can go in and do that same inspection by putting that camera up to a window in that electrical cabinet, looking for any loose connections. Of course, they'll show up as a hot area, and then only focus on those during the next outage. From that standpoint, I've lowered the risk for everybody involved because they're going to be spending a lot less time exposed to those cabinets.
Yeah. This is kind of interesting. When it comes to product design, which comes first, safety or reliability, and which one has improved more in recent years?
I think that there really is no choice there. If you make an unsafe product, you won't be making that product very long. I think you can see how much some of the major auto manufacturers have suffered over the last few years due to recalls. So I think from that standpoint, there is no choice. The product has to be safe first and then reliable. If you can't do both of those in the long term, you may not get to make that product very long. So, but I think safety definitely comes first for most of our products today.
And you have to take that beyond product design and talk about product manufacturing as well. If you can't manufacture the product safely, you're cutting into whatever profitability you're getting from the reliability of the product down the line.
That's a very good point. Absolutely, Bob.
And on a similar note, how do we prioritize low-risk equipment safety concerns in a day when many items with the safety label are given precedent over high-impact equipment uptime improvements?
Well, you know, this is a great time to take our root cause skills that we talked about a little bit and heard in the video and dig a little deeper into that problem and kind of begin to understand what might be contributing to them throwing everything over into that safety bucket. And I can tell you from my experience, many times operations will throw that safety flag on jobs that they want to get done because in the past they've had to wait too long to get it through the work order process. So they do the same thing for emergent repairs. You know, if you've got a lot of backlog within your facility and it takes you a while to get work done, if I'm in my area, I'm tired of waiting for it, I'm going to use safety or I'm going to use emergency to get that job done faster. So while I know that's not always the case, I think from a maintenance and reliability standpoint, it really behooves us to take a look at what we might be doing and what the root causes are that are driving folks to put those things in those categories.
This is kind of an interesting one because it goes to a different level of safety. And what's the best method to improve a good safety program to turn it into a best program? The question is, it seems like safety needs constant reminders, but how do you mix it up without it becoming the safety program of the month?
Well, absolutely. You know, we all feel that pain, and to be honest, what I've talked about here today could lead us to feel that same thing around reliability. But I think what you've got to do is begin to ingrain these things into the culture and the way we do business and not necessarily always call them out as safety. But if you've got a really good safety program and you want to get to excellent, take a look at what's left. You know, I've been in some really good safety performing facilities, but their reliability was so poor that it just amazed me all the steps they had to go through in order to be safe in an unreliable facility. The risk is higher. They're having to wear more PPE. They're having to really do a lot of additional labor and a lot of additional effort that if they could just improve the reliability of those assets, they would lower their exposure, lower their cost, and improve their reliability performance without even saying, improve their safety performance without even saying the word safety.